I got your message, and I am never busy if you're going to send me messages about how to do maths questions. So I'm on my own laptop. I'm going to share my screen. That means I'm going to black out. So hopefully I'm sharing my screen. You're sharing the screen. Yeah. Okay. Cool. So finding the unknown side in a tetrahedron, I assume you're doing this question here from the textbook. So I've taken a screenshot of part C, and I'm going to quickly work through that now for you. I don't have my pad, so it's going to be a bit clunky, but hopefully this helps you. So the one piece of information that we don't have in this question is the height of this tetrahedron. We need that so we can find the surface area of the 3 triangles that aren't the base, if that makes sense. So we need to use Pythagoras' theorem. Now, Pythagoras' theorem works for any right-angled triangle. Let me see if I can create a right-angled triangle. I can. Woo, yay. Okay. So that's a right angle because it's got the corner angle is 90 degrees. Now, always directly opposite from a right angle in a right-angled triangle is the longest side, and we call that the hypotenuse. I'm just going to run through Pythagoras' theorem for you because you did mention that it's a lot to think about at the moment. So we call the hypotenuse C when we're thinking about Pythagoras' theorem, which is this formula here. And then the 2 other shorter sides, it doesn't matter which one's A and B. We just call them that by convention. So we know if it's side C, it means it's the hypotenuse, and then the shorter sides are A and B. Now, if you take the length of one short side and you square it and you add it to the other short side length squared, A squared plus B squared, that is always going to equal the length of the hypotenuse squared. I showed you this example in class, but I'm just going to show you again. That's my brother calling. Okay. So let's say the side of A was 3 centimeters. If we square that and we add it to, let's say B was 4 centimeters, and we square that, that's equal to 9 plus 16, and that equals 25. That means that the side length of C, well, that means that C squared, is equal to 25. Now, 5 times 5 is 25. So that means that C has to be equal to 5. Okay, so that's how Pythagoras' theorem works. And I can, when we move to geometry later on in the year, I can show you different ways to prove that formula. But we'll just use it for now. So thinking back to this example, it's only slightly more tricky than what I've just shown you. So C in this case, or the hypotenuse, is going to be this 65 centimeter length, because if you can see that black line that I've drawn down there, that is creating a right angle with the bottom or base of this tetrahedron. So it's creating a 90-degree angle. That means that across from there, just like it's across from here, that means that the 65 centimeters has to be our hypotenuse. So I'm going to chuck that in there so we can move to an easier looking diagram. So that's 65. Now we just need to work out what A and B are from here. We know one of them, but it's not 44 centimeters. Because if you create a straight line from the top, it's actually halfway along this side length here. And I know that this side length is 44 centimeters because that one is, and they've both got one dash of the diagram. So this full length here is 44 centimeters, but I only need half of it. And I'm going to call that B because it's on the bottom. Right, the example is from the textbook. Okay, so we know that C is 65. We know that B is 22. So the only unknown we have, if we go back to the formula, the only unknown we have is A. We know what B is, so we can find out B squared, and we know what C is, so we can find out C squared. I'm going to remove some of this. So if we have A squared plus 22 squared, and equals 65 squared. We do these calculations on my phone. So 65 times 65 is 4,225, and that equals A squared, I'm going to leave that, plus 484. Okay, now this is where we need to think a little bit algebraically. We need this unknown, this letter, by itself on one of the sides. It doesn't matter if it's the left side or the right side. Because it's already on the right side, I'm just going to leave it. So I'm going to take this plus 484 over to the other side. And when we do that, we have to use the opposite operation. And 425 minus 484 is 3,701. Why did I do that? That's really confusing because the only thing we have left on the other side is A squared. But 4,225 minus 484, this thing, this calculation here, that equals 3,741. Now that's A squared. We don't want A squared though, we want A. So the opposite to squaring something is finding the square root. Let me use the calculator on the laptop, which I haven't used in ages, so it might take a while to load. Please skip ahead if you can't be bothered waiting. Okay, so the square root, where's the bloody square root symbol? This one. Okay, so I'm going to click that after. Do this 3,741. The square root of that is 61 centimeters, 61.16 centimeters. That equals A. So now you have the, well, now we have the height of this triangle here. And in this case, that triangle and the one on the right, the right, and then the one behind, they're all the same triangle, the same size. So now you can go base, which is 44 centimeters, times your height, which is 61.16 centimeters, times those two together and divide it by 2, because that's how you find the area of a triangle. And you just times that area by 3, and you've got all of those 3 triangles, and then you just need to find the one on the bottom. which will be the base 44, again, times by your height, 38.1 centimeters, and then divide it by 2. Then you add that onto the other 3, and then Bob's your uncle. I'm going to leave it there and watch that. Let me know how you go. That's been 10 minutes. That's not too long, is it? Anyway, let me know how you go and flick me through on Teams any more questions, or you can chase me up in our lesson on Thursday. Thanks, Matthew. I'm going to start recording now.